So how many people we've got here?
32, it says.
32. Okay, much better crowd. All right, so sorry about that. All my fault, I guess. Blame it on me.
Did you actually link on the other ones for the other people to join here?
Yes, I did. Post the links, so they're going to be coming in, I guess, shortly.
All right. Okay.
So where were we? Let's go and start the recording. Well, actually, the recording is already started. Let me go and share my screen real quick. And we are back in business. All right, guys. So sorry about this one more time. Again, maybe start a little bit from the beginning. So those of you who are new, I am Teo Lachev, and helping me today are Damu. We've got John, and I'm sure we have other people from the community that have been helping us all along. So welcome to our November 1st, 2021 meeting. So quickly going through some of the organizational side of things. If you are new to the group, if you haven't been with us before, our primary group site after the demis of SQL Pass is the meetup. Please go ahead and register so you get notifications and all of this. A lot of people asking, where are the recordings? You know, the cool recordings so we can watch it after the meeting. So here is the link right here on the screen. https://bit.ly Atlanta BI Rex. So this link here is going to bring you to the YouTube. And on YouTube, you're going to see all the recordings that we recorded since we became virtual, right? So if you want to get a little bit more involved, if you get business value out of these meetings, please spread the word, let your coworkers know. If you want to get a little bit more involved, always looking for speakers, people passionate about BI, Power BI, come and actually do us a presentation. So I'm looking for speakers for next year, actually. On the subject of jobs, this is actually where we stopped with the previous meeting. Does anybody have any job openings that you want to share with the community? Anybody looking for BI talent? Anybody? One more time? It looks like not. Well, if you have something, if you think about something that you want to share, job related, put it in the chat window. Other than that, I'm going to keep on going. A few things about events that are coming up. Microsoft Ignite, the biggest Microsoft conference, starts tomorrow. So if you haven't registered, it's free event. Haven't registered, go ahead on the website. Go ahead and register. It's a free against conference, and you can watch all the sessions and quite a bit of Power BI sessions in there that I saw today. Then we have the PASS Community Summit next week, actually November 8 to 12, Monday till, what is that, Thursday or something like that. Again, another free conference, not to miss. Everything around SQL Server, a lot of BI content as well. So this is the two conferences, probably the best conferences for the entire year. Make sure to sign up. You will learn a lot, promise you. Okay, we're gonna get to the questions in a moment. On the news side of things, so not much happening because of the end of the year, but a few things that caught my attention since the last time we met, which was, what was it, October 4th. So a common requirement, especially if you work for large organizations, is now that we spend so much money on Power BI, who's actually using Power BI? And more importantly, all these data sets that we have that are consuming resources, is actually anybody using them, right? Since the last time they were deployed. So we have a new REST API called Power BI News Artifacts API. Not a big deal, but it will be a good segue for me to show you how REST APIs work in Power BI in a moment, and how you can actually test them without writing a single bit of code, right? So we'll take a look at that in a moment. Believe it or not, if you're using data flows in Power BI, and if you don't know what data flow is, this is essentially think of it like ETL for business users, which is based on Power Query. Appreciate if you can guys mute yourself. Getting a lot of background noise in here. And maybe I'm gonna do a favor to mute all of you. If you want to ask a question, please unmute and ask the question, but there was a lot of background noise. So I was saying that the data flow is essentially self-service ETL. Data analysts want to do some transformations. They use Power Query, either in Power BI desktop or in the cloud inside Power BI service. So now we have something called streaming data flows, which allows you, if you work with things like IoT or data that is always streaming, but it needs to be transformed before it's displayed on a dashboard of some kind, then there is a feature called streaming data flow. And that streaming data flow, there are new features in it. So take a look at that if this sounds interesting. And then we have the integration with Azure Purview went into general availability. What is Azure Purview? Imagine you work for, I would say, a relatively large organization, and you've got a lot of artifacts, not only Power BI, but you're using lots of technologies, maybe Azure Data Factory to put data into a data lake, and from data lake, it goes to Azure SQL database, and from Azure SQL database, it goes to a data mart, and from data mart, it goes to Power BI. So Microsoft has never actually up to this moment had a solution for data governance, right? So if my question is as a manager or as an architect, how is that data flowing end to end from the beginning to reports? So that if I change something, what's going to be the impact? What's going to be the impact analysis? So we never had a good answer for it, right? But then we have a technology now called Azure Purview, which is an Azure service that allows you to do that, allows you to actually inventory your data sets. And Power BI can integrate with that. So if you have Power BI, if you're using Power BI, you can actually integrate it so that you can trace the entire chain. You know, what happens even before the data gets into Power BI with that data before it gets into it and before we have a data set and reports and so forth. So that integration went general availability. If this sounds interesting, please take a look at it. So this meeting is going to be demystifying Power BI AI visuals. Sandeep Pawar is going to do it. And the next meeting is going to be on December 6th. I'm trying my best to recruit Patrick LeBlanc again, although he went blank for the past few days on me. So we'll see what happens in there. But hopefully we'll be able to finish on a high note. Patrick is going to come up and tell us about whatever he wants to tell us. He's always very entertaining. So before we go to the main presentation, I want to show you a little bit. I want to show you about this unused artifacts API, but also while I'm doing this, I want to show you how we can work with Power BI REST APIs, kind of give you an idea. So behind the scenes, a lot of stuff in Power BI is actually programmatically available for developers to use, such as if I'm a developer and if I want to do some automation, maybe enumerate the data sets in my organization, or programmatically deploy Power BI files. There are APIs, and these APIs are called REST APIs. So if I go and I search for Power BI REST APIs, I'm gonna see the documentation in here. And when I see the documentation for the REST APIs, I'll see that they're organized in groups. Right, so there are plenty of them. I remember when we started 6 years ago, there were like 4 or 5 APIs, and the number has grown to a lot of APIs. So if you're a Power BI admin, probably the group that will inspire the most interest is what? Is the admin group. Because this group, the APIs in this group, some of these APIs allows you to do things across the tenant. For example, get all the data sets across the tenant or all the users and do some interesting stuff with that. So typically using these APIs require developer experience. You gotta write code, PowerShell, .NET, whatever code you're familiar with, whatever language you gotta write. But what is cool is that we have this test harness here online inside the documentation that allow us to test the APIs. And if we want to get the results from these APIs, we don't have to actually write a single bit of code. So to demonstrate this, I'm going to use one of these APIs that just came in. This is unused artifacts. So my question here is that my organization using Power BI. I want to see what is the last time a data set was accessed, because it hasn't been accessed for a long time. Maybe I can go ahead and nuke that data set, right? So I can go to this, click on this API, see what it's doing. And here is the magic button in here that says, try it. Well, that looks very nice. By the way, just without being a developer, one of the things that I want to know is what parameters this API take. And this curly brackets in here tells me that it actually takes one parameter that needs to be replaced. So this particular API, for some obscure reason, you have to specify a workspace. So you cannot use it across the entire tenant. So you got to do it workspace. We used to call workspaces groups. So every time you see group, you automatically replace this with a workspace. So it needs the workspace identifier, right? So I'm going to go and click try it. And it's going to take like a minute to go enumerate all the tenants that I have access to. But meanwhile, let's go to Power BI and let's choose one of the workspaces that I have access to. So here's Atlanta BI workspace in Power BI. So what I'm going to do here, I'm going to copy this GUID. This is the workspace identifier. And there are different ways to do it. You can click on the data set. Actually, you can go to the workspace properties, but it's usually after groups, because again, workspace used to be called groups. So I'm going to copy this identifier because that's what the API requires. And I'm going to go in here and I'm going to paste that identifier right here, because again, this API takes a parameter. So we're not going to worry about the other stuff here. We're just going to go ahead and click run. And we click run. What do we get? We get all the data sets in this workspace that I specified. And for every workspace, what do I get? I get the data set name, but the most important also the size in megabytes. But also the most important thing that I'm probably going to be interested in is this last access daytime, which is in UTC. When you see that Z, that means this is UTC timestamp. So now I can see. Now I can see when was that data set last access. So what does last access means? If I have a report that actually is based on that data set, then this is where when the user run the report, the last time they run it, this is actually where the data set was last accessed. So now I can have this information, I can copy it. This is actually, this schema is called JSON, but I can go and actually there is a online, there are all different JSON viewers. If I want to get a nice table, I can do that. Or I can just analyze like this, it's pretty self-explanatory, right? So that's my little tip that I wanted to give you today for accessing Power BI REST APIs, where you don't have to be a developer. You can go and run each one of those APIs. Some of them require permissions. So this, for example, requires Power BI administrator or Office 365 administrator permissions. But some of them do not, like for example, the workspace specific APIs. If you're a member, I think that should be sufficient. So take a look at what we've got, and I'm sure you guys will find different ways to take advantage of that. All right, so do we have any questions? Let's see. Screen is frozen. I hope, guys, you can hear me loud and clear, and the screen is not frozen for you. Okay, so now I understand. We forgot to update the link. It's entirely my fault. So actually this meeting was the previous one that we had, but yep, sorry for the mixed up. Looks like we don't have any questions. If you do, please post them in the chat window. Meanwhile, I would like to transition to the main presentation, and I would like to invite Sandeep to tell us all about Power BI AI visuals and how you can work with them. Sandeep, you there? Damu, do you know what happened to Sandeep?
No, I don't know. He was on the other meeting?
I hope not. Do you have his cell phone?
Let me see.
Let me just see, maybe he sends. Ah, there it is. Okay, okay. Well, so sorry. He's actually patiently waiting on the other meeting. Okay.
So, yeah, given the link for the new one, the one this is.
Do you have that meeting handy down?
Yeah, I'm going to reply to him.
Okay. Thank you. All right. So while we're waiting for, I'm sorry about this. While we're waiting for Sandeep to join us, how do we fill that void? How do we fill that gap? Any questions? Power BI or beyond?
Okay, well, I'll take the chance. My name's Rajesh, and we're looking for any tips to speed up a slow refresh on my PBIX file. Right now, it's taking upwards of 30 minutes.
Is this Power BI Premium or just Power BI Pro?
Right now, it's in a premium workspace, but it's not on Power BI Premium capacity.
Well, how could it be on the premium workspace if it's not on the capacity? Are you using by any chance premium per user licensing maybe?
Correct.
Or using
you are correct. You are correct.
Okay, so it doesn't matter. A premium per user, for the most part, is the same as Power BI Premium. So my advice, probably the first thing that I will do when I troubleshoot refresh issues. Now, quick as a bunny, actually, probably I won't be able to show you right now because my capacity is paused. But if you go to your workspace settings, and if you go to Premium, you need this link in here. This is called XMLA endpoint because behind Power BI, it's analysis services, right? So what we can do once we have that link, we can open a tool called SQL Profiler that has been around for a long, long time. You will get that tool when you install SQL Server Management Studio. So when you install SSMS, you automatically get the profiler. So go to the profiler and I would do what? I will log in. I will log in now that you're in the premium. That's a good thing because you can actually use the profiler. I will choose here Analysis Services Tabular. I will plug in that link and I will say this is Active Directory Authentication. So you plug in your name, your password, and you click connect. And when you do that, the profiler is going to connect to your workspace, and it's going to intercept all events happening against that analysis service instance. So all queries are going to be intercepted. Also, all refresh operations. We call them process. You used to call them process. You have to look at events that actually relate to processing. And basically what I'm going to be looking there is how long does it take to refresh table per table, right? So maybe one of the tables in your model is the culprit. Maybe it's based on a view or some kind of I'm not sure what they did behind the scenes, but maybe that view has a lot of joins and kind of slows the whole thing down. So take a look at the profiler because it's going to give you table by table what's happening. It will show you how fast the data is coming up from the data source, right? And then once I do that, I will have a kind of a good understanding of where the time is spent and where should I focus my next effort. Make sense?
Fair enough. Thanks for the guidance.
No problem. Do we have Sandeep? Yes, we have. Sandeep, can you hear me?
I can hear you, sir.
Sorry, Sandeep. I have to go to Power BI prison today because I did horrible, mix up with these links. I forgot to update the one on the meetup. I sent you the one that I used to use, that I have in my schedule. So sorry, but you're good to go.
Okay, perfect. Let me start my camera for a bit so that you guys can see me.
and then I'll turn it off while I'm doing the presentation. So, hello everyone. Thank you, Atlanta Group, for having me here. Really excited to join you. I have attended some of your sessions in the past, so thank you. It's an honor to be with you here.
Thank you for coming.
Sure. I share my screen and turn off my. Okay. Okay. Can you see my screen? Okay.
We can.
Okay. So the topic today is Power BI for demystifying Power BI AI visuals. And as the name suggests, what we are going to do is we are going to look at some of the AI, the so-called AI visuals in Power BI. And we will go a little more than what the documentation gives you. These visuals are very powerful, and probably some of you are already using it. Please drop it in the chat window, which of the visuals you use, how do you use it. We will demystify it because it so for some people, whenever the word AI comes, it sounds like we're trying to do something that is out of our hands, something that the visual does or Power BI does for you. What we are going to do is peel that a little bit and look inside and then figure out how exactly these things work. And how we can use them better in our reporting and then finding insights. So before I begin, I just want to take a moment to remember Ferenc. If some of you knew him, I did briefly. He was part of the data platform community and a community member and shared his knowledge with all of us. Certainly with me, I benefited from his knowledge. He passed away exactly a month ago. So just wanted to take a moment to remember him and his contribution to the data platform community. Happy Diwali to those of you who celebrate Diwali. I do. So happy Diwali to you if you celebrate it. Even if you don't, happy Diwali. A little bit about myself. I'm a data analytics engineer at Cree Lighting in Wisconsin. My background is actually in the mechanical engineering. I was a research engineer focused mostly on product development and a lot of numerical computing, and then got into data analytics 5, 6, 7 years ago. Primarily work on the Microsoft BI stack, like most of you. I blog at pawarbi.com, and I'm very active on Twitter at pawarbi. So follow me if you're interested in Power BI related things. The AI visuals, we are going to look at clustering, key influencer, decomposition tree if time permits. Time series forecasting, I will touch upon that because it's one of those things that is used very frequently in the business by the businesses. Anomaly detector and Q&A. Now that's a lot on the agenda. What I'm trying to do is some of these things are covered by Microsoft in their documentation, and some of them are not. So, for example, clustering is one thing that I know Power BI team hasn't covered much. Key influencer is again one of those things, and time series forecasting. Decomposition tree, I use it, but there is not a whole lot to talk about it other than it's a cool visual. And then anomaly detector, it's still new. We'll talk about that a little bit. And then the Q&A visual is also something that I use very frequently, but that's a big topic in itself, how to set it up and use it correctly. So if we get to it, I will share. Otherwise, we might have to do another session for that. We're going to start with clustering. And first, what I want to do is maybe bring everyone to the same page here, what exactly I mean by clustering. So there are two things, clustering and segmentation. If you are a business analyst and create Power BI reports, you are probably very familiar with maybe creating segments based on some static or dynamic DAX measure. So for example, in the first picture we have here, X1 versus X2, some column X1 and some column X2, and this is the scatter plot. and each blue circle here is an observation. We can create a DAX measure that gives us maybe a median or an average of the X2 variable. And it doesn't have to be a median or average. It could be a percentile line above, below, based on what your data is and some sort of insight that you're trying to draw out of it. You could also create a quadrant chart. So you would create a median line on the X and a median line on the Y, X1, X2 here, and then maybe identify which the point falls in which of the quadrants. So that is a segmentation. And then we as business analysts are very used to doing something like this, and the business users as well. They are very used to uh, understanding data like this. Let me go here. Clustering, on the other hand, it's a machine learning technique to find groups of data that are based on similarity of attributes. So what that means is, if we look at the same data that we looked at here, so this data, clustering, it's going to look at the pattern in the data, and then based on the pattern, it will create these clusters for us. So in this case, we used a simple heuristic. So if it is above an X1 line, below the X1 line, above the X2 line, below the X2 line, and then define what that segment is. In this case, we don't know beforehand what the clusters are. And Power BI, or the algorithm that's used underneath it, it will identify those patterns for us. So in this case, it identified three different clusters within your data. So this blue, then this one, and this one. You can also see roughly they have not equal number of points in them. So it doesn't have to be same number of points within those clusters. How does it work? Without going into a lot of technical details, what I want to do is just give you a quick understanding as to how this works, because if you understand how it works, it will also help you understand how to use it correctly. This is one of those things that's not included in the Power BI documentation, and I had a very hard time figuring this one out, that which algorithm does Power BI use. K-means, if you are somebody who's who knows about machine learning, you're familiar with K-means clustering. And one of those basic algorithms that's used for clustering in machine learning. But it's not mentioned anywhere in Power BI documentation. And even in the Power BI team, when I reached out to the product team, it took a while to get the answer from them, because not many people knew about it either. So the way the K-means clustering works is, let's look at the first, let me see, my Zoom it is working. Yeah, let's look at the first iteration. This is our data. It will start with, we have to specify the K in K-means. We tell it how many clusters we want to create. And let's say we start with 3. It will randomly create three points, and then it will calculate the distance between this point, the newly created point, and the points that are near to it, and then it will calculate the distance. Okay, and then it will keep doing that to find which of the points are closest to that cluster. So if you see here, we started with this point is closest to these 3 points are closest to this. Maybe this point is closest to this red X over here, and then it goes through the iteration process several times, and then arrives at which centroid these 3 points does it belong to, which is what's happening over here. At a very high level, what this is doing is it's optimizing it for 2 different metrics. First, it's going to look at it's going to form the clusters based on minimizing the distance between the points within the cluster. So how tight the points are or how close they are within a cluster. And then it's also going to maximize the distance between different clusters because it's want to separate out. So we want the X1 cluster to be completely different or as separated from X2 cluster or X3 cluster. So it's optimizing for those two things. And we don't have to do anything. Power BI does it for us. So that's a little bit of a technical discussion on that. So let's go over to Power BI, and then we'll start analyzing and looking at how this works. So what I've done over here is this is a retail sales analysis data. If we go to Google, and then if you look for Power BI samples, it should give us the Power BI samples. If we go to Power BI samples, somewhere down below here, you will find the retail, yeah, there you go, retail analysis sample PBIX. I'm using that exact same thing. And the reason I wanted to do that is I just wanted to show you that in your own existing reports, how you can use clustering and then some of these AI visuals, your own data to enhance the experience of your users and draw more insights and go beyond the traditional business analytics or data analysis that's done. So very typical looking dashboard. This is some pie chart and scatter plots, some bar charts, and new store sales. So this data is basically sales analysis by region and then by stores, and then we have a date table in here as well. And we want to get some more insights out of it using these AI visual. So let's see how we can do that. So we can start off with using the creating the scatter plot. Okay. And I've created a scatter plot in the when you download the file, you will see there are a bunch of different measures that are already created. One of those is this year's sales and last year's sales. And the idea here is, can we predict this year's sales based on the last year's sales? That's why we want to plot these, and each of these are, I think, by store. So this is this year's sales versus last year's sales by the store. So each of the dots are stores here. If we just visually looking at it, and if I were to ask you, create two clusters from this, we would create, naturally, we would create a cluster maybe that says stores that did 200,000, so 0.2 million, so 200,000 or less, and then 200,000 and less this year and last year. That's in one cluster, so maybe low performing. And then these are the high performing. So it looks like 1 over here, and then 2, perhaps maybe 1, 2, and 3. But so this is what we would do if we were not to use any clustering algorithm. To create a cluster, what you can do is, once you have created a scatter plot, first we're going to start off with a bivariate cluster. Bivariate, bi means 2, and variate means 2 variables. So we'll start with bivariate cluster. We will click on the ellipse here, so the 3 dots. So click on the 3 dots, and then up at the top here, you will see an option that says automatically find clusters. And we'll click on that automatically find clusters, and you'll be shown, let me zoom in here. You'll be shown a few things here. So first is asking us for what do you want to name that cluster, which field you want to cluster it on, and then some sort of a description and the number of clusters. So the number of clusters, if you recall with what we talked about just a few minutes ago, the K-means, K is the number of clusters. In K-means algorithm, you have to specify yourself first how many clusters you want. In Power BI's implementation, it does that for you. It does that for you. You don't have to specify it, and it will go through the process, its optimization process, and it will figure out how many are the optimal number of clusters. Okay. Here, you can call it whatever you want. I'm gonna call it, let's say, bivariate, and then click on OK. As soon as you do that, Power BI is now running that K-means algorithm for you. and then it will also drop it into the legend field automatically for you. So it dropped that bivariate cluster name that we created. This bivariate thing, it's neither a calculated column or a measure. I don't know what to call it. It's just some sort of a derived. It's a measure maybe. It's something that Power BI creates, but there is no formula attached to it. Or it is a calculated column though. You can see that as a column. But there is no formula associated with it. There is no DAX formula with that. Power BI found there are 3 clusters, and interestingly, the 3 clusters are not same as the clusters that we would have thought. The first cluster it created is this blue stores over here, which understandably low sales. But it split these two into 2 separate clusters. So we have, if you can't see it here, this is an orange cluster. This is an orange color here, and these clusters are assigned a red color to them. So it found 3 different clusters. And how did it do that? Well, it went through, like we just talked about, it went through that process, and then it found that stores in these clusters are different enough from each other and then close enough within each other. And that's why those are like that. In this case, it is very easy to understand why that could be the case, because maybe in this case, these closed stores over here, they overlap each other, whereas these ones, they are maybe scattered a little bit from each other. So maybe that's why RBI thought that, okay, these 3 clusters are different from each other. When you, a couple of things that I want to point out in using scatterplot that not many people are aware of. When you are using scatterplot, by default, it always plots 3,500 data points. Okay? And the way you know that is if you go to the format pane option here and then go to general and then look at the data volume right over here, it says 3,500, and you can increase that or decrease that. By default, the high density sampling option is always on. And what that high density sampling option does is if you have points that are more than, so you have more than 3,500 points, turn this on and off and you will see the difference. When you have the high density sampling option, Power BI will automatically hide the points that are overlapping each other. In this case, we have, I think, 1,500 maybe stores or something like that. So it won't work here. But if there are points that are or circles that are overlapping each other, with high density sampling, Power BI won't show them, even though they are there. And it can give you inaccurate insight or based on what your needs are, what you're trying to do. So just be aware of that. So you can turn that on and off. When you go to the analytics options over here, 3 things that I want to point you out here. So the first is the trend line. Let's drop that. So we create a trend line. There is another thing called symmetry shading. And the third thing is ratio line. And I want to take a moment here to talk about what each of those lines mean and how do you use those in a scatter plot, and especially when you are creating clusters and then identifying insights from this. This is also part of the whole AI thing or the AI visuals in Power BI, but it doesn't get talked very often normally. So the trend line is actually a linear regression line. So what this is telling us is it will find a line of best fit, if you're familiar with linear regression. And then the purpose of showing a trend line in an analysis is to show whether there is a correlation between your X and the Y variable. And that's all it does. The ratio line, on the other hand, these two are very close to each other, so the difference is not much and perceptible. But the ratio line, on the other hand, it's there is no statistical base to it. It is just the sum of your y divided by sum of your x. So you can think of it as a slope, and it always goes through the 0 point. So this is the ratio line is, you can think of it as an average, total average. If the points fall above the average, in this case, this is the red line is the average. If the points fall above the average, then you can safely draw an inference from that point is above the average. So this is a quick way for you to understand which points fall below and above the average. And the third thing is this symmetry shading thing. And for a long time, I did not understand how to use it and what it means, and what context do you really use it. So the symmetry line, as the name suggests, it's just basically symmetry. Meaning there is a one-to-one correspondence between your x and y. So if you follow this, if I draw a line, point 3, then there is a point 3 over here, and this line will intersect that point. So the symmetry is one-to-one correspondence. So if you are trying to compare something that has one-to-one correspondence, then symmetry shading is very helpful. So in this case, let's say your goal is not to compare the average, but your goal is to compare how exactly did it compare to last year. So the points that are on the symmetry line, then they did exactly like last year. Otherwise, they are not. If they are in the blue, then they did considerably better this year versus the last year. So on and so forth. You get the idea. So that's how the symmetry shading and these things work. Okay. So let's get rid of these over here. We can further draw the bivariate created here. The next thing what you should do is take the bivariate, put it in here, and then maybe find out what is the number of clusters you have. In this case, we have 66, 14, and 20. So it created clusters that are not equal in size. So this is bivariate clustering. The next one is multivariate. As the name suggests, multivariate just means that you are trying to create clusters based on multiple different multiple variables in your data. And the way that works is, let's suppose we start with let me put it over here, and then do that. We can start from scratch. So I'm going to go to name, which is my name of my store. Then all the KPIs that are already there, average, I'm going to drop it here. There should be one for margin variance. I'm going to take it, drop it here. Then sales per square foot. So let's take that, drop it over here. Total variance, percentage, take it, drop it here. Regular versus markdown is another one. So if that store, a high regular versus markdown ratio means that store sold more regular items than markdown items. Okay, so I think that's about it. Those are the ones we created. So these are the exact same thing. I just wanted to show you how I did it, but I already have that exact same table in this case. So we drop the measures here, and to create the cluster, in this case, we follow the same process. We click on these 3 ellipses here. Click on these 3 ellipses, go to automatically find clusters. Click on the automatically find clusters. Give it some name. In this case, I'm going to call it multivariate. Even in this case, I'm going to keep the number of clusters as auto. and then click on OK. When you are creating a model, a machine learning model using K-means clustering using Python and R, you usually have to go through identifying what is the minimum number of minimum optimal number of clusters that you can create. There's an elbow method and a lot of different things that you have to go through, silhouette index. And so Power BI, in Power BI, you don't have to do any of those things. It just does that for you. So which is good. You don't have to mess with any of those things, and it just works out of the box. So just like that, it created clusters, a multivariate cluster for us. So what did it do? It again went through the same process. It looked at the pattern in the data, and then based on the distance matrix that we earlier talked about, it created 4 different clusters. So I'm going to drop that multivariate here. And then let's take this and then apply. Yeah, it created, sometimes you may see this cluster 1, cluster 2, and there might be a blank. And that's just because maybe you have some null values in your data or missing values, and that's why it created that. When we drop it here, it should get rid of that. So it created 4 clusters now. And now if we take the same scatter plot, and we take this and then drop it here. I'll maximize this a little bit. Now you can't really figure out in this one where the cluster 1 is, what cluster 2 is, cluster 3, cluster 4, just based on this year's sales and last year's sales. And that's the power of doing clustering in Power BI, because now you're going beyond the 2 dimensions, and then you are looking at the pattern in the data that is just not possible for you by manually looking at different matrix or creating DAX measures or creating anything. But now the question is, how do we know what each of these clusters are, right? Because it created the cluster, and what we talked about earlier, it will try to separate out or create these clusters so that for some of these clusters, maybe the age factor in here, these are newer sales. Some of them maybe the average unit price could be higher or lower, or it could be different from the other. But how do we know what that is? And that's where the inside part of the cluster comes in. So it is not enough to just create a cluster, but you have to go one step ahead and then figure out what these clusters are telling us. The way to do that is using what's called as a parallel coordinate chart. This is not natively available in Power BI. You'll have to download that from the custom visuals library, and then you will get it from there. So I already went ahead and then got it the parallel coordinates by XViz. Let me zoom in a little bit. Parallel coordinates XViz. There are a couple of other variations of this, different custom visuals. I found this one to be the easiest to use and works pretty well. In general, I'm very hesitant always to use any custom visuals because of the security reasons, and also because you never know when it will stop working. But XViz, I think it's pretty well known. It's Microsoft certified, so you can use it. So let's create a parallel coordinate chart. Let me make this smaller a little bit here. What we're going to do is in the categories, it's asking you 2 things, basically, the category and the value. Okay. What I'm going to do is I'm going to take multivariate as my category and then drop it here. And then I am going to take the same values that we use to form these clusters. So the first is, let's say, the age. I'm going to drop it here, the average unit, I'm going to drop it here, regular versus Markdown, I'm going to drop it here. Let's see, total sales variance, here, sales per square foot, and then margin variation. And now let's take a look at these things. So this blank again is because it doesn't have enough data, so we can get rid of that. Multivariate, and then let's get rid of that. Okay, now let's try to understand what this is telling us. If you see right away, the way you you read these this parallel coordinate chart is, if the things are, if the lines are crossing each other, then that means they are going in the opposite direction, obviously. If the things are going parallel to each other, then they are going going in the same direction. And that's how we know how these clusters are created. If we look at the first plot here, see on the x-axis, if we can. Hopefully that's big enough. But if you look at the first one here, age, it clearly separated the stores into two different groups. The first group is 0, meaning new stores. And then second group is age is 4. So those are the older stores. Again, remember, we did not specify what is new or old. It found the pattern in the data, and then it identified, okay, there are two clusters within this. The first is the new and the old. Then within even the stores that are new, they are behaving differently again. So if we focus on just the old, let's say, the old stores, there is a cluster within that, within the old stores, that are doing quite well. They're selling high, they have high average, they're selling products that are higher on price compared to the other one. So this one is selling 7.2, so $7. The other one is selling on an average $5 worth of product on an average. Then the next thing that we look at, regular versus markdown, and this may indicate that's counterintuitive here though. So it's saying they are crossing each other, so they are behaving completely opposite to each other, and there is no correlation between the two. Then most of these stores, they seem to be concentrated fairly well in regular versus markdown, but not so much in margin variations. For margin variations, they are spread apart quite a bit, and maybe that is another factor that is distinguishing them from each other. And this is how you can get a lot of insights out of it. Because remember, we started off with something. We want to understand what are the different clusters. And now we can figure out, okay, the new stores page that was created here by default, it has your typical analysis, right? What is the sales per square foot and this and that. Whereas in this case, we found that the sales per square foot, where is it? So right over here, and these two. So we are looking for these two. So even within these two, there are two segments that are doing differently based on if it is defined as a new versus old. You can also use this to create matrix, right? Or rather the measures, right? Because now if you know what is the average, or what is the distinguishing factor. So these two, for example, the cluster number 2 and then cluster number 4, these two are doing really well on margin variance. So so this is a percentage, meaning it did significantly better in percentage compared to the last year. Whereas this blue line is cluster number 3, they did not do as well. So that's how you create and identify insights from this. If you look at even the if we create, for example, actually, let me just take it from here. Then drop it. And then look at multivariate and then drop it in the legend. You can clearly see that how these four clusters are segmented or differentiated from each other. They are pretty much parallel to each other and they are behaving differently and even in terms of sales and everything. So it all matches, right? How well did Power BI do? Did it do a good job in identifying these clusters? So just to give you an idea for it, for example, I ran through the same analysis in a Jupyter notebook using Python. This is that key thing that I was talking about, that how to identify the number of clusters. We won't go through the details here, but in general, if I can just show you a little bit, the AUC, the area under the curve, or we can use it as a proxy for the accuracy of this, 91%. So it is 91% we are able to identify these clusters and how different they are from each other. You can use the same approach for time series data. And this is a pretty advanced technique to use. So what I'm doing here is for each of these stores, I created measures. You can use calculation groups if you want to create this. But what I've done here is on the first column is these stores. The second column is my January sales for the January, sales for February, and then up to July. So I've pivoted the data, and then instead of creating matrix, if you create a matrix, you can create this in matrix, right? And it will work. But clustering does not work with matrix. It has to be a table. When you create this, it like this, now you can add your other things that you had in here to this data. So margin variations, and maybe you can look at age and all of these. And then now you can run your clustering algorithm on top of that. So automatically find clusters. And what this will do is it will go through again, follow the same process, but now it will identify it will cluster the time series for you and then find products. Maybe I've found insights that are very hard to find otherwise. So for example, this is a synthetic data, so it doesn't give you a good example here. But imagine you have all of these different products and you want to find products that did well in July, but not as well in maybe October, or products that are just on an average low compared to the median compared and to the rest of the group. Usually when we are creating or identifying clusters, we do it by product category, the typical hierarchy, right? Product category, or maybe this, that, and then you look at that. But this is a different way of looking things. I may go back to this over here, the page that we created. You can also create a map, for example, and postal code. I'm going to drop it in the location and then name as my legend, maybe. Okay. Maybe the sales. So if we look at the sales per total sales as my size, and now I'm going to drop that multivariate as the legend, and now see how, without even specifying how any geographical location, how this data is clustered together. Now it's very easy to find, right? So this blue line is cluster one. So cluster one is basically in maybe in your neck of the woods in the southern part of the United States, and then you can try to answer, or you can try to figure out, okay, in this blue dots, which is cluster 1, what is this red one or this orange one is doing? Maybe on an average, these stores are doing well, but this orange one is the one that is not doing as well. So, so on and so forth. So basically, it will try. You can get many more insights out of this if you use clustering. Another technique that is very common is, let's go over here, and then we'll go to the so when I went over here and then I clicked on this key influencer visual, you can couple the key influencer visual with this. So the key influencer visual over here, the key influencer visual, it tries to identify its opposite of, we can think of it as maybe something very that's very opposite of clustering. In clustering, you don't know beforehand what the clusters are, whereas in key influencer visual, you are trying to identify maybe for some sort of a group, or maybe for some category, or maybe some continuous number. How is that influenced by the other measures that are in your data? And the way Power BI does that is it's actually very cool. It's creating a machine learning model. It's creating a linear machine learning model and in insight service. So when you create a key influencer visual, it takes a key influencer visual, runs a DAX query. So it will create a DAX query and then run it using .NET in analysis services, train the model, get the results back, and then visualize the results it does all of that for you in a fraction of a second, which I think it's pretty cool. And it does a pretty good job of that. Underneath it, there is not a whole lot that's going on. The cool part here is the implementation, but the algorithm that's used behind it, it's pretty basic standard, your linear regression and then logistic regression. So if you are analyzing a continuous number, let's say you are looking at a continuous number like sales, right? Then that's a continuous number. Logistic regression is used for categorical data. So the cluster that we talked about, good versus bad, or maybe high versus low versus medium, or something like that. And it will that's how it works. So let's try and see how that works. So what I'm going to do is, in this key influencer visual, I'm going to do some reverse engineering. I'm going to take the multivariate cluster that we just created, and I'm going to say, analyze that for me. And what do we want to analyze it by? The same thing that we had earlier. We are going to look at it by age, regular versus markdown, age variance. Let's see, what were the other things we had? Can actually be easier if I just took this. And then converted that. And we want to analyze it by multivariate. And then we'll drop it over here. There we go. So the first one we don't care about. The second one. So up at the top here, you'll see a couple of different things. So the first one is key influencer. This is tab number 1. The second is the top segment. So these are 2 different tabs, and they serve 2 different purposes. Okay. Cluster 1 is, let me get rid of this. Cluster 1, you can drop down here, and then I'll select cluster 1. It's saying cluster 1, what differentiates cluster 1 from the other clusters is the age goes down by 2.8, which means it's a new store, because average age is 2.3 or 2.8 or 3. So now it so the cluster number 1 is your newer stores. What is another distinguishing factor for cluster number 1? Regular versus markdown goes by 2.06. So what this is saying us is if you keep all other things the same, for cluster number one, you sell more markdown products. So cluster number stores in cluster number one, they sell more cost down product versus regular product. And then the average unit of, and for all of these, it will give you what does it look like. So the number one factor is age, and then you will see for cluster number one, the age is small, cluster number two, age is small. And what is the median, and then what is the distinguishing factor. When we go to the segments up at the top here, you get the traditional segment in that. So even within cluster number one, it found two different segments within cluster number one. If you see at the bottom here, it says segment one, and there are 32 stores in segment one, and then 10 stores in segment number two. So in cluster one, there are total 42 stores. And how are they different? Well, let's click on this and see what's happening. So when you click on this, you'll see that for cluster number one, the first segment is such that the average average unit price is greater than 5.61 and is less than $7, whereas for the other one, it is greater than 7.1. So even within your cluster, it found more segments or pockets of data that are different. And again, this is something that no matter how good you are with data modeling or no matter how good you are with DAX measures and everything, you will not be able to find these insights or pockets of data or segments of the data by just creating DAX measures. You'll have to, if you had to do it manually, you will have to just go through a lot of exercise to do it in a meaningful way. So that's how a key influencer works. Now the key influencer visual, it's good, but as you can see from the long list of things I have over here, there are limitations to that. First thing that you have to understand, and sorry, this is really small here, but I wanted to fit as much as I can. I'll zoom in and then you can look at it. But the first thing is that it will not treat the outliers for you. So what that means is, because we know now that if the key influencer visual works using linear regression for continuous variables and then logistic regression for categorical, the limitations of those two algorithms apply in case of key influencer as well. So if your data is such that there is no linear relationship between your X and Y or your variables, then it will not work. So the meaning of that is, let's say we have this, and this is your X, and this is your Y. If it is a linear model, it will be like this, right? And we'll be able to predict it accurately within using key influencer. If it is something like this, really wonky, then you will not be able to capture that just with linear model. Unfortunately, Power BI won't throw an error. It will still run and it will still give you, but it won't be valid, right? It unfortunately doesn't work that way. So always plot and explore your data. Best way to do that is, like I showed you earlier, create scatter plots and then maybe do the trend lines on it to identify what's the best fit line there. It will impute the missing values for you. And one big limitation is, let's imagine you have 100,000, which is very typical, right? You have 100,000 data points, 100,000 observations in your data. And you run the key influencer on it. Key influencer actually samples only 10,000 data points out of that. And it will, I don't know if there is a logic to how it does that. I'm guessing it's random. And it has nothing to do with what we talked about earlier, the 3,500 data points. But the So it will sample 10,000 data points. So which means that when you create this, there is a chance that you may not be able to capture the true relationship between your X and Y variables or your all of your variables. So just keep something in mind. And I guess the last point that I would mention here in terms of limitation is that if you don't know how to draw insights from the key influencer visual, and if you can't explain it logically, then don't put it in front of your business users because they'll be confused and there are high chances that they may draw some incorrect conclusion. In my own personal work, I've actually never put a key influencer visual in front of my business users. It's something that I use very often during development to identify, okay, which of the columns should I include, and what should I do, basically. And then I use that as a tool to inform my decisions. But I don't necessarily show it to my business users because they won't understand it. And then if there are limitations or if they interpret it incorrectly, then that's not good. Okay. The last one is, let's see. Here is the time series. I think Theo, correct me if I'm not wrong here, but I have 15 more minutes.
Yes, we actually
Okay.
have, I would say, up to 20 more minutes.
Okay,
maybe
that's good.
With some time left for Q&A.
Yeah, sounds good. Okay, so the last one is forecasting, and this is a topic forecasting is something I do very often. And no matter which type of business you are in, forecasting is pretty much required, and it's basically maybe the most used predictive modeling thing in the industry. So what we're going to do is we are going to look at some data, and we want to understand. We want to forecast something. In this case, it's sales for a French retailer. It's a real data. It's a quarterly data, and I'll show you that in a minute. And we want to forecast for the next 2 years. And we want to understand how these forecasts are created, what algorithms are used by Microsoft, by Power BI to create those forecasts, what are the forecast assumptions, how accurate is the forecast, what can we do to improve those forecasts, and then when does it not work, which is very, again, important to understand. Another thing that unfortunately Power BI hasn't done a good job of explaining in their documentation on how forecasting really works. So to answer the first question, how does the forecasting in Power BI work? Is it uses something called as exponential smoothing class of algorithms. If it is a seasonal data, seasonal meaning it has some repetitions in it. So the sales go up during summer months, go down in the winter months, or the opposite way. They go up, certain time of the year or certain time of the month, and things like that. There is a repetition to it. Then it is seasonal data. If it is a seasonal data, it uses this ETS-AAA. We'll look at that very briefly. And non-seasonal ETS-AAN. And it imputes the missing values. If there are values that are less than 40% are missing values, it will do linear interpolation and then just calculate it for you. It will detect the seasonality, and we'll look at that a little bit, and then create the forecast for you. So what exactly is this exponential smoothing? Well, exponential smoothing, a quick way to explain that is, imagine you have this time series over here. What exponential smoothing does is it assigns some weight to your observation. So let's say we start with this. We are here right now, and we want to forecast what's going to happen in the next 2 years. It will take the current value, assign some weight to it, let's say alpha value to it. This value is between 1, 0, and 1. So let's imagine this is 0.8. And this value, observation, is 1,000. Last quarter, maybe we did 500 units instead of 1,000. Alpha value, this alpha, it's going to use the same. So this is 0.8 multiplied by 1 minus alpha, which is 0.2. So this is 0.16 basically. So this is 500 multiplied by 0.16, which I'm not mistaken, that's 80. And this is 800. So it will take 800 plus, what did I say, 18 or 16, and then add them up and then give you the forecast for the next quarter. And the reason why it's called exponential smoothing is because if we plot these values, so I started with 80%. If you see what weightage is assigned to the past values, past observation, it diminishes in an exponential way. So it will assign 80% to the last quarter, 16%, it will take 16% of 2 quarters ago, and then 3% a quarter before that, and then literally nothing before that. So it diminishes exponentially, and that's why it's called exponential smoothing. And this is for if the data is non-seasonal. If the data is seasonal, if it has some thing to it, it will do decomposition. It will identify the trend in your data, apply this exponential smoothing part. Then it will identify the seasonality. What is the seasonality in your data? Apply that exponential smoothing part, and then combine them, all of them together. And what it uses, what I said earlier, ETS-AAA, it will use this ETS-AAA. And this is one part that you have to understand, that even if we don't get to the demo, and if you want to understand how this works and when you should use forecasting in Power BI or not, this is the critical part. The ETS-AAA is based on additive trend and additive seasonality, meaning if the trend in your model or your time series is such that it just goes up like this linearly, then you can use this Power BI forecast. If it is something like that goes up like this rapidly, it's accelerating, then Power BI won't be able to capture that. Or if it is decelerating like this, so it is increasing, but it is decelerating quite a bit, then again, even in that, that's called damp trend, and Power BI won't be able to capture that either. So, so that's important thing to keep in mind when you are creating, when you are trying to figure out if the forecast in Power BI is going to work or not. This ETS algorithm itself, it's used. I use it very often, and it's really good. These are just some of the advanced algorithm, and this is the error. And you can see ETS, for example, it beats pretty much every other advanced algorithm that's out there on an average. So when it is applicable, you should use. You can be confident that okay, Power BI is doing actually pretty good job of that. And how can we create the forecast? Well, there is not much to show really. If we go here, and then I'm going to add my sales data to this, and let's get rid of this, and then let's create a line chart. And this is the nice data with some trend, and we know that because we can add trend line here. So it's increasing in the trend. If you see that you've added the trend line, but your time series is deviating from it, going up or going down, that's a good way to know if it is going to work or not in your scenario. So for forecast, what we're going to do is the bottom here, I'm going to go to forecast, click on the forecast, and then just click on add button. And it will ask you how many data points you want to forecast. And in this case, I'm going to say I want 8, What do you want? I want to create 8 quarters, and then apply, and it will give you that. The limitation here is that even if you add labels to this, it won't show you the labels for the forecast value, which is very annoying. I don't know why they did that, but which is a big limitation in my mind. Also, this gray shaded area is a 95% confidence interval, meaning you can think of that as an error in your forecast. So in this case, as I mentioned earlier, Power BI actually imputes the values for you. So let's say I deleted some of the values from here. So it automatically imputed the values for me. So if you see, I deleted a value, so it automatically did the value before, the value after, took an average of that, and then added that value over here. And I can create a forecast here, for example, and I'll show you why I'm showing you this in a minute. And let's create 8 points quarters. Apply. Now, if you see here, look at the width of the confidence interval here, the gray shaded area. It's higher over here. It's thicker compared to this one. And that's because, as I said earlier, Power BI is less confident about this one. That's why that band is thicker. That's an indication of how much uncertainty you have in your forecast here. Now, if you're curious about the forecast and how it's created and all the technical details and everything, just go to my blog at Power BI. I've written quite a bit about it, and you can see it over there. One thing that I would like to point out here is when you are creating the forecast, if we go again, there is an option here called seasonality down here. Most of the times we leave it out as is. But whenever possible, you should enter that value whenever you can. And the reason for that is, let's say I create a forecast here. This is an actual data. It's a monthly data, and we want to create a forecast here. Okay, so I go here and then create a forecast, and now look at how the forecast is. Does this look? I mean, there is no reason to believe that your trend is downwards. So everything is pointing downwards, and the forecast is saying it will jump up significantly over the next 10 points. And the reason for that is because of the way Power BI calculates seasonality. We won't go into the details. We don't have enough time here, but that's because how Power BI calculates seasonality. If your data is monthly, the seasonality number is 12. If your data is quarterly, the seasonality number is 4. If your data is weekly, your seasonality number is 52. And that's something you should keep in mind. I know this data is monthly, so I will enter the seasonality as 12 and then apply. And when you do that, now that looks much more reasonable. Look at the thickness of the prediction interval here. It's pretty thick. So the forecast is, yeah, it created the forecast, but that's just one indication that, okay, there is not enough signal in your time series to create accurate forecast in this case. So always enter that seasonality value. Another thing, while we have a couple of minutes over here, is when should you use time series forecast in Power BI and when you should not. You can use it confidently if there are no outliers in your data, if there are no missing values in your data, and it is a low frequency data. Low frequency meaning if it is like monthly or yearly or quarterly data, then you can use the forecast in Power BI. If it is maybe weekly and more frequently than that, like a daily or maybe hourly or I don't know, bi-weekly or something like that, then you should not use Power BI forecast. And the reason for that is this ETS algorithm that we just talked about. It assumes a single a seasonality. It has to be one single number. If it is multiple seasonalities, which is always going to be the case when you have like daily data, because if you're collecting the data daily, you can imagine you may have data daily, but it will go up. Maybe after a while it will go down. So there are multiple seasonalities that are going on. And when you do that, you won't capture that seasonality in your data. It will just create a single exponential smoothing. So it will just be a single line. It won't be a nice looking forecast with all the seasonality captured in it. So just keep that in mind. That if you have time series data that is high frequency, then the forecast that you're going to create with this is not going to be accurate. Now, if you do want to create the forecast, you can either use Python or if you go here, yeah, you can create some dynamic forecast using Python and then opt in all the, everything related to that and create nice KPIs and DAX measures and all of the nice things with it. But just something to keep in mind. Again, our goal is to create or to give our business users accurate numbers so that we can explain. If you create a forecast, but if it is not good enough, if you're not confident enough, then there is no point in showing it to your business user. Maybe just use it for yourself and then use it. Now, when it is applicable and when you are able to use it, how well does Power BI forecast work? It does a pretty good, reasonable job. So if this is Power BI 8% for this time series data, if I use Azure ML auto forecasting 6%, if I use the Python 6%, if I go more advanced ensemble modeling forecast and everything, it goes down to 3%. So there is always room for improvement. Again, if 3% improvement is going to make you millions of dollars, then yeah, that's something you should look at. If it is just maybe you're forecasting some quantity that would be 100 versus 110, that's not going to change much. Then yeah, may as well just use Power BI forecast for that. So yeah, I think that's about it. Sorry, we did not get to go through the rest of the stuff here, but hopefully, with whatever I covered so far, we went in depth as much as I could, and you were able to get something meaningful out of it.
Oh, that was also awesome, Sandeep. It was really, really cool. Very
Sure.
in depth. So we're gonna invite you again to, I guess, cover the rest because it's so
Sure.
interesting. But I wanted to ask you a quick question, if you don't mind.
Sure.
So when you talk about the high frequency, in your example, when you did the initial forecasting, you lowered the grain to date field in the date dimension. So initially, when you drag it and drop it, it was the hierarchy, and then you remove the hierarchy, and then you went to the date. So isn't that high frequency data then, because you're going all the way down? Shouldn't you be at the month level, quarter level, something like that?
So for this one, for this data, I did not remove the hierarchy. So when we were looking at, so this is a different data altogether. So when I go here, there is not much to it. This is, if you look at it, there is no date dimension to it. This is just January 2012, January. And although this is saying it's giving you the date, there is not the data in it. So let me show you what I mean by that. It's just this much. So it's an aggregated data. So we have date, sales, and this much. So this is already at the quarterly level. But you're right. If you have the data that is at lower granularity, then you should go up and then make it as coarse as you can.
Excellent.
Now,
nice.
That's an interesting question here. I just want to point out one more thing here is, let's imagine you have which hierarchy do you choose? So let's say you have monthly data, and you can also go to quarterly data, and you're asked to create a forecast for the next for the next 2 years, right? Should you forecast next 8 quarters, or should you forecast next 24 months? Know what I'm saying? And that will, and the answer is going to be actually different. So if you create a forecast based on the monthly data and then forecast 24 months out, and then you calculate maybe that number, and then also do the same thing with the quarterly data, the numbers are going to be different just because of the way the algorithm works. You're always safer to go coarse and then use quarterly data because you are less susceptible to the noise in the data. If you have more data, then there is a chance that you may the algorithm may learn from the noise and give you more inaccurate forecast. If that makes sense.
I always thought that having more points, more historical points, actually is better, to make the algorithm more precise. But
so that is
like,
I mean, that is valid, and you should do that. And so the point here, for example, the time series length, how much time series, so that is different from how many points you should have in your forecast. So let's say you want to forecast next 2 years. Because of the way the ETS algorithm works, if you have seasonality in your data, you should have at least 3 to 4 times the seasonality number. So what that means is, let's say your seasonality is monthly, which is 12 seasonality. So you should have at least 3 to 4 times that number. So 36 months to 48 months,
nice.
right? And then, but again, what I mentioned in my exponential smoothing, we are not going to use all of that, because if it turns out 80%, then it's just going to use maybe the last 5 months or last 5 quarters. So even if you have like ton of data, it's still not going to be the results are not going to change significantly, right?
Great. So I assume you also have, I guess, presentation for the rest of the Power BI features, because I think there was a question here in the audience that somebody needs a question about session about Q&A, and also we have Get Insights, and also we have the anomaly detection, and we have the auto ML and all that stuff. So do you have presentations for this? Maybe we can invite you next year to kind of continue.
Yeah, sure, absolutely. I would be happy to.
Awesome, great. Do you guys have any questions for? Okay, so there is a question from Aziz. He's saying forecast. Could you please repeat the thicker portion?
Yeah. Yeah, sure. So let's go over here. So the easy way to explain what that is let's suppose how many people are here? So we have 15, 16 people over here. I take a sample of 5 people, okay, and I ask them, what is your height? And we calculate the average of those 5 people, and that number comes out to be 5.2, okay, 5.2 feet. Now we collect more data, and then we go to, we ask all the 15 people and then calculate the average. And that number comes out to, again, 5.2. But which one would be you would be more confident about, the first one or the second one? The second one, because you have more data points, and to express that how confident you are, is something called as a confidence interval. Confidence interval measures the uncertainty in your estimate. When you are creating a forecast, it is nothing but, it's technically, in statistical terms, it's called a point forecast, because it's just a mean of all the different things that we are looking at, and it's just a mean forecast. So the forecast is actually an average of all the different things. And to express how much uncertainty is in that mean, you create an prediction interval around it. If you go to my blog, Power BI, there is a section that I've written on this exact same thing that goes in more detail exactly what it means. When you are creating forecasts, you not only want to create a forecast that is accurate, but you also want to create it so that it is less uncertain. So always keep an eye on the width of the confidence interval in there in your forecast. If it is very thick, then that means your forecast is inaccurate, or there is just not much accuracy in it, and so make your business decisions with a grain of salt. Think twice about it.
Got you. Awesome. And we have one more question here. Where do you view the actual forecast data values if you can see them in the line graph?
Yeah, good one. So when you go to here and then look at show as table, you will see it right over here. Now, interestingly,
doesn't it show on the tooltip though, Sandeep? If you hover on
it
top
is
of that data point, no,
it is not. Unfortunately, it is not. You cannot get that in the tooltips. If you want it in a tooltip, if you think that what Power BI has created is good enough, here is a trick that you can use. Go to Excel and then create a forecast. I'm using the exact same data, okay? And then create a forecast and now see if you see anything similar. It's creating the exact same forecast that we created because it's using the exact same algorithm, the ETS algorithm that we just talked about, and it's giving you the exact same output. So everything is working exactly like Excel. So there is no difference actually between Power BI forecast and an Excel forecast. And what we talked about, that you should always use Power BI forecast for maybe quarterly and yearly data. So which means if you create an Excel sheet, you will just be updating it once a year or once a quarter, which is good enough, right?
Yeah. Got it. Well, great. Any other questions, guys? We are close to the, I guess, end time. Anybody else?
I got a quick question. Hey, first of all, great presentation, Sandeep, and happy Diwali.
Yeah, thank you.
So the question I have is about, I saw you use some custom visuals and stuff like that. So I have some data sets that's connected to a tabular model. And I noticed that there were some that I was unable to use because of that, at least through my research. Is that true? Are there any workarounds? Should I come up with a composite model? What's your thoughts on that?
So I have not seen, so I use a tabular model, and honestly, I have not seen any limitation as far as custom visuals. I'm actually surprised to hear that. I mean, once
I was trying to use like Q&A and quick insights.
Oh yeah. Okay. Yeah. So with that, yes, you probably are right on that one. For Q&A, the thing is, for Q&A to work, it has to be meticulously planned for it to work correctly. You have to, there's the pain that you have to go through to set it up. It's a lot. You have to set up your relationships really well. You have to have the right amount of permissions. It has to have right amount of granularity. It has to be named correctly. Things have to be hidden. You cannot show your natural key and things like that. And then it will work correctly. So you're probably right. If you're using a composite model, Q&A, that might be one of the limitations. I'm not exactly sure, but I won't be surprised.
So these ones you showed will work?
Oh yeah, these should work. The Q&A won't, but these should not be a problem. Should work right.
So John, for your information, the Q&A actually it's a preview feature, so you have to enable it in Power BI Desktop, and I send you a link in the chat window for that. So Q&A, I think that will work if you have a tabular model, but insights like explain, increase, decrease, I believe they still don't work for some obscure reasons. So maybe you're 50%, you'll be able to have 50% success rate between the two features.
Okay.
Worst come to worst, tell them time to move our tabular model to Power BI Premium, to be on the latest and greatest. And then when you do that, maybe everything will work.
All right, thank you.
Well, anybody else? Well, I guess that's it. I want to thank Sandeep. Sandeep, are you planning to share the PowerPoint slides?
Sure, absolutely. I can do that. I'll email it to you and you can share it with the crew.
Yeah, whatever is interested. But thank you so much for
Thank you.
doing this. This is really, really
Appreciate the
cool.
opportunity.
And guys, I'll just give me an hour for the hour or so for the recording. And once it's done, I'll put it on YouTube. And I guess I'll see you. I'll talk to you December 6th for our last meeting for 2021. Thank you so much. Have a great
Thank you.
evening.
Hey, thank you,
Bye.
Sandeep. Thank you so much. It's Damu here. Yeah, thank you. Thanks to you, Dr. Deer.
Thank you, Damu.
Bye.
Bye-bye.